Welcome to this Voice of Innovation, and very privileged to have the opportunity to welcome here Mark Lundstrom, the founder and CEO of Radia. By way of background, few people have had the entrepreneurial success as Mark, from biotech to telecom to aerospace, and he's now turned his focus to energy and energy transition, in particular to wind, and we're very privileged to have him share his experiences and have this Voice of Innovation with us. And what I'd like to start by just asking Mark, how does somebody who's a ski racer go from that to becoming an entrepreneur to becoming an energy entrepreneur? Give us a little bit of a background of your journey.
I'll answer that in one second, but this is an amazing opportunity and experience for Radia because, as some people may know, we just unstealthed less than a week ago. And so this is the first time they've actually had a chance to speak publicly about what we're doing. So thank you for that. And also thank you for personally doing the interview, Jamie, because a lot of people here, I think, don't necessarily realize that you're the co-founder of CERAWeek, the new people. And so I just want to thank you for taking the time. From ski racing to entrepreneurship. It was an amazing journey. So I ended up studying rocket science, basically, at MIT, and did that not for the purpose of ever being an engineer, but instead being the purpose of a business person that would be developing products subsequently. And so really viewed my education as being a systems engineer and looking at systems engineering very broadly and thinking about how does technology and business and policy all come together to make products and make products successful and to make economies competitive. And so spent many years at MIT doing undergraduate and graduate work, and then eventually jumped straight in, never had a real job, just jumped straight into starting companies.
I thought it had to do with speed.
Yeah, it was
ski racing. You like
it was. Well, the thing that's
you like wind in your face.
The thing that is different about ski racing is it's a sport where every day the competition is different, right? The course is different.
Yes.
And every day in entrepreneurship everything is different. So there's some parallels there, I suppose.
Yep, that's great. So why energy? So you've started so many companies. How did energy catch your attention?
Yeah, energy was a fairly clear choice in some ways because, ultimately it's the fabric of society, right? Whether it's fossil fuel or whether it's renewable, it's one of the most important things in our life, in our society. And if you think about energy, you can almost think of it, if there was a Maslow's hierarchy of needs for countries, you can think of that for energy, right? Where there's like energy poverty, and then there's energy security, and then there's energy transition. And as we started to think about renewables, we realized that renewables can actually impact all of those different dimensions, right? Energy poverty, in many parts of the world, it's very difficult to get wind turbines distributed. And so being able to do that can help address energy poverty. Energy security is becoming a bigger and bigger issue these days because of obvious reasons. And so having some indigenous supply of power generation, renewable power generation, is fantastic. And then energy transition is something which almost comes after energy security. And it's something that's almost a luxury in some places of the world. And so energy transition is one of the most important things then to focus on in the long term, of course. And then the way that we all got into this at Radia was it was really a response to the turbine manufacturers who together teamed up and said, we know how to make offshore turbines that are nearly the size of the Eiffel Tower. We just don't know how to deploy them onshore where the market is 10 times bigger. And so a press release came out from arch rivals, from competitors, saying, can an aerospace entrepreneur come and help us fix this challenge? It's a transportation challenge. And so could somebody come and help us move gigantic offshore-sized turbines to onshore locations?
I think you've anticipated my next question, which is the idea of putting together aerospace with renewable energy is not exactly intuitive.
Yeah. So it was fairly clear when the market sort of speaks to you, when arch rivals in a big industry team up and say, we need an aerospace solution for something. And so that was very clear to us that there was an opportunity, a multi-trillion-dollar opportunity to unleash the next generation of wind energy by being able to move these very, very large objects. And so it was clearly an aerospace solution. We looked at lots of different options for that until we finally consolidated on one particular solution that we'll move into manufacturing for shortly.
What was I'm curious. What was another option?
You know, when you start off looking at different ways to move objects by air, you can look at rotorcraft, you can look at blimps, you can look at fixed-wing aircraft, and for lots of reasons. And we did look at all of these, and then ultimately realized that the best thing to do was to make a large fixed-wing aircraft in order to move very large wind turbine blades.
Well, some of you have seen the Wall Street Journal article, which was really amazing coverage, featured story this last week. And I was blown away by the photographs, actually. Greeting me one morning, I looked up and I said, wow. So normally we don't do this, but I thought for everyone here, it'd be really fun to actually see what this looks like.
Yeah.
Because unless you see the breathtaking scale, you don't really get it. So,
Yeah.
So
yeah, let's throw up a couple of pictures. Probably have like 4,000 words worth of pictures. Right. So some of you have seen turbines being transported on the road before, of course, and they create a lot of bottlenecks on our highway systems. And if you see the picture here, it's a 70-meter blade. And if you imagine trying to move an offshore-sized turbine blade, those blades are up to 100 meters plus. And so being able to transport those terrestrially becomes increasingly impossible with every additional meter that you add on to a large blade. And then, and so what we've been doing at Radia is solving this by creating what will be the world's largest aircraft. And so this is a vehicle that's about 12 times the volume of a 747. It can land on dirt. And what the design team has done over the years is focus on making an aircraft around the tier one components that already exist. So this is really just a lot of existing aerospace technologies that are integrated together. Nothing new here, except for the size. And so it has the capability of moving a 105 up to 105 meter blade. And the capability of landing on relatively short dirt strips. And so this will enable the industry to move straight to wind farms and land large objects at the wind farm. It's very similar to military cargo planes where you nose load and can put very large cargo in there. And so you can see there 295-meter blades being loaded in. And we have the ability to move wide tower segments, long blades, alternative payloads as well. In the end, it's a fairly simple structure. And there we go. And so this enables then moving from sort of standard wind today to what we call gigawind. And standard wind would have a typical capacity of 3 to 6 megawatts. And if you can enable offshore-sized turbines onshore, you can bring that up to 6 to 10 megawatts. And so that's enabled by moving the blade length from like a 70-meter blade to a 105-meter blade because the power output scales with the square of the blade length. And so you're able to get a lot more power with a little bit more additional length on the blades. And then a result of that is you have a huge decrease in the cost of the energy, a huge increase in the capacity factor, and it also triples the acres in the world where wind is economically viable and allows the developers and everybody in the food chain to sort of double the IRRs on projects. And so it's a really powerful step function in the world of renewables. We have one more. I think that was it, maybe. Nope, good.
There's the best picture. It's really amazing. As I look at that, I wonder, what were some of the big technology hurdles or that you're either facing or have faced to create an aircraft of that scale?
Yeah. So one of the beautiful things about this is there's really no new technology in the aircraft. What the team has done an exceptional job of is looking at the different components, the tier one components in the aerospace supply chain that are already flying and already certified, and integrating them into a very large aircraft. And so the vast majority of the things that are embedded within Windrunner are things that are already certified in production, flying today. Mm-hmm. And so the aircraft has been designed around those different tier one components. And so that really reduces the technical risk, reduces the schedule risk, And so it ends up being more of a supply chain challenge, an ecosystem challenge. And then if you look on the turbine side of the business, the industry knows how to make very large turbines, as evidenced by mass production of the turbines being distributed in the North Sea. And so there's really no new technology there. And in fact, big turbines onshore involve a simplification or a dumbing down of some of the complexities that are necessitated for offshore turbines. Initially, though, when we start distributing these, we'll likely just start distributing the turbines that already exist today, because there's most of the turbine manufacturers, they have their best-selling turbine and they have their biggest turbine. But these are different, even though the bigger turbines are usually much more powerful and much more economic. And so the ability to move the biggest turbine to many more locations opens up a lot more economic opportunity.
Right. I'm curious, the landing on the short, that must have been an interesting challenge, such a large aircraft.
Yeah.
They'll actually design or build airstrips, I suppose.
Yeah, so consider these, they're not airports. These are dirt strips, and they have roughly the surface quality of like an access road at a wind farm. And so it needs to be straight, it needs to be a little bit wider, a little bit longer. But relative to like a 747, the landing distance is probably about 2/3 of the landing distance. And so you're able to have a fairly short landing strip, and it can be dirt. And so it's a very unique aircraft, and it has the ability to land relatively slowly. It's closer to the landing speed of like a Cessna than a 747, and then it's able to slow down on a fairly short distance. And then for taking off, which is also a challenge with field length, there's a lot of very, very powerful engines on the aircraft, and so we're able to get out of a fairly short dirt field as well.
Yes, I was going to ask about the drivetrain and what engines are you using, and are you partnering with?
Yeah, so we've chosen some of the best-in-class, most powerful engines in the world that are already in mass production and already flying on commercial aircraft today. But instead of using 2 of them, like most commercial aircraft do, we're using 4 of them on the Windrunner.
Right. So does it use SAF?
So it's designed absolutely to use SAF, to be able to accommodate SAF. And we're completely committed to doing that as soon as SAF is available. And in fact, we intend to help make SAF available, because at Radia we have not only the design team to design and then procure the aircraft, but then also we have a development team, and the development team is working on projects that do include SAF projects. And so because with the bigger turbines, of course, you can make cheaper green molecules, and cheaper green molecules, whether take hydrogen into SAF, and we think we can help reduce the cost of sustainable aviation fuel significantly with the much bigger turbines.
So if we can take an aircraft view of this, just stepping back and say, what problem are we solving?
Yeah.
We've heard here at CERAWeek already about the acute concerns over the future of power demand, the growth of power demand, and how we're going to meet it. How does this fit into the bigger picture of the energy ecosystem?
Yeah. So. I think all the power demand numbers have generally been underestimated, right? There's giant exponential waves coming up from a number of different applications that are growing quickly. If you look at e-vehicles, of course, rapid growth. In the not too distant future, e-vehicles will be 50% of the vehicles that we're driving. It's going to put a huge load on the grid. We then have heat pumps. Heat pumps are going to start to be a fairly large demand for green energy as well. You can reduce the household emissions by about 64% if you're using heat pumps. And so that's going to be a big driver for climate change. And as those start to proliferate, as they have in Europe, and they one day will in the US as well, I think, that also puts a big load demand. And then the third big area is like AI data centers. This is something that even the hyperscalers, I think, didn't really have a concept of how much power generation was going to be needed. And so these AI data centers are putting a gigantic new unanticipated load onto the grid. That's going to be very challenging. And it's interesting to observe that the power demands from AI data centers, that really scales with Moore's law. And renewable generation scales with cranes and screwdrivers. And so there's a widening gap potentially between the demand and the supply. And so with GigaWind, with these bigger turbines, we can help shift that supply curve a bit and provide a lot more energy with the bigger turbines.
Is gigawind is that a trademark that you have? And that's a
It's a term that we use to describe the larger turbine.
large turbines.
Yeah.
So I'm sure you've looked at the geography and the map and the wind resource available. Where do you see this having its greatest impact?
Yeah. So one of the beautiful things about the bigger turbines is they operate in much lower wind speeds. And so if a standard turbine requires, for example, 7 meters per second, the bigger turbines can operate in under 5 meters per second average wind speed. And so when you look at a map of the world where 7 meters per second exists and 5 meters per second exists, you basically triple the acreage in the world where wind can be economically viable. And so this enables you then to get into new areas that are not crowded with wind already. It enables you to get into new transmission opportunities and actually obviate the need for as much transmission. Because if you can bring the generation much closer to the demand, then we can shorten the amount of transmission that's necessary. It also gives you the opportunity to help put behind-the-meter projects next to harder-to-abate industries that might not be next to the traditional renewable acreage. And so there's a lot of really exciting things in terms of being able to expand the acreage and expand the market.
This sounds it's very similar in my mind to what fracking and unconventional did. You sort of no single innovation, but the combination of innovations which creates a disruptive outcome.
Yeah.
And in this case, you're basically unearthing a huge new...
Yeah, and if you think about what the industry, you can sort of view this as the industry is waiting for something to unlock the ability to build onshore turbines that are similar to the size of offshore turbines. And everybody benefits from that, right? The aerospace community benefits from it, the turbine manufacturers, the wind farm developers, the green molecule manufacturers, the hard-to-abate sectors, everybody really benefits from it. And so as long as we can create this enabling technology, like fracking, it opens up an entire new industry and a lot more profitability in that industry as well.
So, of course, the solar folks are not sitting still either.
Yeah.
And we're hearing about perovskites and all the new breakthroughs. How does this compete, or how does this compare with the wind, solar?
So solar, I think GigaWind both competes and complements solar. And certainly solar can be the cheapest energy in the world if it's a sunny place in the middle of the day. But we can't assume that, and so there's absolutely times when solar can be the cheapest. However, if you look at like the Lazard data, where they looked at where can the cheapest energy come from, they look at natural gas, they look at offshore wind, they look at solar, they look at onshore wind, and in their data they say that onshore wind is actually cheaper than solar on average. Not cheaper than solar in Arizona on a 3 o'clock in the afternoon, but cheaper than solar on average. And then gigawind is even cheaper than onshore wind. So we believe this is the path to the cheapest energy. Now, solar will keep going down. The solar modules will keep going down in price. In cost. However, the balance of plant starts to become a larger and larger portion of the total cost of a solar farm. So even if the solar modules keep going down, it starts to catch up with the balance of plant, which is harder to decrease. And also, if you just think about solar, the Earth rotates on a daily basis, and the Earth orbits around the sun on an annual basis, and those two things determine where the good wind and good solar resources are. And so in the end, solar and wind end up being very complementary. And so solar ends up being better during the days, wind is better at nights. Solar is better in the summer, wind is better in the winter. And so that's a wonderful complement to each other. And so as the grid grows and as the grid starts to embrace more renewables, it makes a lot of sense to invest in both of them in parallel. And it makes the grid a lot more stable in the end. And if you look at those trends that we were talking about earlier, things like EVs, heat pumps, and data centers, especially with EVs and heat pumps, over time the trends will start to favor wind. Because EVs, as the EV fleet grows, when do you charge your EV? It's going to be at night, not during the day. Right. And so it complements wind a lot better than solar. Today, the peak energy is usually during the days because of air conditioning. But as heat pumps proliferate, the peaks will be at night, and the peaks will be at night in the wintertime instead of the days in the summertime. And so all of these things, all these trends start to favor wind, and especially larger wind.
Right. Of course, we heard from our Secretary of Energy that she wants to go big on geothermal.
Yeah.
So that'll be another layer of the.
Yeah, and I think geothermal will be a fantastic base layer because intermittence, even with gigawind, there is some intermittency, and so having some amount of base layer does help. It'll ultimately be, I believe, more expensive, but it's a good complement as well. And so as you look at how the grid evolves, there'll be solar, there'll be wind, there'll be geothermal. It'll be a nice combination of technologies.
Well, you've mentioned the applications, and obviously data centers are one of them. But when you look around the challenge of getting the power to where it's needed, and we're hearing now about the manufacturing rebirth in America, the Renaissance, and including in some of the heavy demand loads, even from the production of oil and gas. So who are you partnering with,
Yeah.
and why?
Yeah. So if you think broadly about what makes a good partner for Radia and for GigaWind, it can be really maybe 4 different sectors. There's sectors like the obvious ones, like wind into the grid. And so being able to partner with IPPs that are interested in having much bigger turbines that can potentially help double the IRRs of projects is one fantastic opportunity. And also, as I mentioned earlier, being able to put larger turbines in acreage that is currently unviable for wind is a fantastic opportunity. The second category, data centers. So data centers, heavy industrials, extractive industries are all other big categories. And if you look at the characteristics of those industries, many of them have large amounts of CapEx, and they want to keep, so whether it's a data center or whether it's an electrolysis plant, you want to keep that CapEx utilized as close to 24/7 as possible. And so with these bigger turbines, you're able to increase the consistency or the capacity factor. And so that gets a lot more return on investment for the CapEx. And so that's true for data centers. It's true for making green molecules. So anytime that you have a lot of CapEx invested and you want to power that with green energy, the GigaWind innovation helps a lot.
Right, right. And part of the context for all of this, of course, is climate and the climate change story. You've done some research, or your team has done some, on the climate impact, which I'd love you to share with us.
Sure. Well, I mean, first of all, if you look at the highest level of why we need to do this, the Paris Accord, of course, set the goal of 1.5 degrees centigrade over pre-industrialized levels, and last year we already broke through that. And the first 3 months of this year are warmer than that, and so we're already way behind on that schedule. And so it's an imperative. I do consider it imperative. And then if you look at the data that, so we've worked with some academics, Professor Jenkins at Princeton amongst them, has done some great analysis with us, looking at what could the impact of GigaWind be on the grid in the United States, and specifically comes to the conclusion that we can reduce the cost of electricity by 16%. We can also reduce the amount of carbon that comes out of the grid by 15 to 30%. And so it's a fairly large
15 to 30%.
15 to 30%. It's a pretty big step function in the world of both carbon reduction as well as economics.
So if this deployed at scale, this helps us effectively a huge leapfrog in hitting the targets.
Yeah, and the other thing about scale, I think, is with better economics and with higher profitability, it'll bring a lot more investment into the category. And so renewables have often been challenged because the rates of return are under the weighted average cost of capital of the big oil and gas companies. And so one of the things that we hope to be able to provide is that with these bigger turbines, we can provide higher profitability and then bring more investment into the sector, both for renewable energy and also for green fuels.
One thing I love is that you talked about the deployment in the Permian, and which is of course a classic, our largest oil and gas basin, which is this convergence of really the energy transition of incumbent players playing with, renewables, and something that I think we're all passionate about is that this is going to be a multi-dimensional energy transition.
Yeah.
Talk about your partnerships with some of the incumbent oil and gas and energy players.
Yeah. So when we started working with the oil and gas community, it was apparent that the first things that were interesting was being able to help them decarbonize their own operations. So being able to help reduce Scope 1, Scope 2 emissions is very important, and most of the major oil producers have made those commitments. And when you use the bigger turbines, it significantly reduces the cost of abating one's own emissions. And so that was sort of the first entry into the discussions with the oil and gas community. But then subsequently, there's all kinds of new green fuel opportunities that are very interesting, whether it's green hydrogen, green ammonia, sustainable aviation fuel, or even using gigawind for the purposes of direct air capture. Because if you look across all those different energy transition verticals, the common thing that hydrogen, ammonia, SAF, direct air capture, the common thing they all have is the unit cost for the unit cost of all of them is predominated by the cost of the green energy that is used to produce them. So if we can help reduce wind energy's cost by 30%, we can then help reduce the cost of all of those different energy transition verticals by approximately 20%. So if you can do that, then all of a sudden you're much more economical for making green hydrogen, green ammonia, et cetera, and it starts to open up additional businesses for us, but also for the oil and gas community that is now starting to enter into green fuel exploration as well.
So tell us about the business model. You're in some ways you're a logistics company. You're an enabler.
Yeah.
On the other hand, what you're delivering is potentially a solution.
Yeah.
How are you going to roll this out?
Yep. Yeah. So if you think, I know when everybody thinks about Radia, you'll think about an airplane, but think of us more as an energy company that happens to have a unique capability to supersize onshore wind. And so while we are going to make a fleet of the aircraft, that is not an aircraft that we intend to sell. It's an aircraft that we intend to operate. And so as an energy company, then we also have a development organization that does go out and develop projects for the purposes of wind into the grid, as well as for the purposes of green fuel production. And so so one way to think about the aircraft, of course, is it's almost like the analog to a jackup ship for offshore wind, right? If these creative jackup ships did not exist, offshore wind would not exist. And if not for this large aircraft, large format turbines onshore would not exist. And so we're seeking to basically build a business around that unique capability and build an energy business around that with us and our partners. And ultimately what happens in the world of energy is everybody wants to find the lowest cost supply. And the lowest cost, you can't control the price, so you have to control your cost. And the way to control the cost is by looking at a combination of the best technology, the best resource, and the best fiscal regime. And so the fiscal regime is very interesting in the United States right now because of the production tax credits. The resource, the United States is blessed not only with good hydrocarbons, but also good wind energy. And then we hope to bring the best technology and build a business around bringing that best technology into wind.
Right. So if I'm you'll be both developing as an IPP effectively with build, own, and transfer, or build, own, and operate?
Yeah, so we do more of the early stage development. And so we'll work on projects up to final investment decision, notice to proceed. That's sort of the sweet spot that we focus on. Don't intend at this moment to be the owner and operator of the assets, just work on the early stage development and then partner them out with companies that have a different cost of capital.
So, but other folks who might be their own IPP could hire your services effectively.
Absolutely, yes. Yeah.
You'll do all of the above too.
That's correct, yeah. So we do, yeah, we do have relationships with IPP. We have sold initial project, and they're large projects that we're working on. So these are usually gigawatt scale projects. And we have been working on projects in the US as well as internationally. So.
Well, I was going to ask you about the international opportunity, but I want to first step back. You mentioned PTC, and I suppose IRA as well. So how does that help you? How are you deploying or using those?
Yeah.
Those
programs? So the IRA, broadly speaking, is just fantastic, of course, for renewables in general. And there's two different components of the IRA that are very important to a company like Radia. There's the Loan Program Office that has the ability to provide fairly large amounts of capital to capital-intensive projects. And then there's the PTCs. And the PTCs, of course, have wind PTCs, hydrogen PTCs, and sustainable aviation fuel PTCs that can stack on top of each other. that really make the economics of these projects much more attractive. Ultimately, with GigaWind, it'll be fine to compete without subsidies, but it is wonderful to help get things started, and especially on the green molecule side. Because in the green molecule side, there's also challenges of bringing down the cost of electrolysis, and so having those extra subsidies on the green molecule side are very important. And as we look at the PTCs in the U.S., we realize there are opportunities to create hydrogen, to create ammonia, to create sustainable aviation fuel. We do think that that sustainable aviation fuel is both because we need it for our own aircraft, but also because there's a great market for it, and also it's really easy to transport once you've created it. You can put sustainable aviation fuel on a railroad car, as opposed to like hydrogen and ammonia that have to go through.
You could put it on Windrunner.
You can put it on Windrunner. Yes. So
really go global.
Yeah. Yes. Yeah. So we are very excited about the SAF opportunities, but also excited about hydrogen and ammonia opportunities as well, of course.
Right. And so you are taking advantage of these jiggers here if you want.
Yeah.
You can make an appointment.
One is made. Yes.
But look, tell us internationally. I mean, you think about this resource. Wind resource is, of course, globally distributed.
Yeah.
And the U.S. is well endowed. But where else are you looking for target markets?
Yeah. So we have been looking around the world at different opportunities. The ones that are most mature for us are projects in North Africa, specifically in Morocco. And I think there's a fantastic opportunity there, both for indigenous energy, indigenous industry, but also for exporting energy to Europe.
Right.
And as a result of the war in Ukraine, there's, I think, gigantic opportunities for renewables and green fuel in North Africa to be exported into Europe. It's closer than the beginning of the Nord Stream pipeline, and it can be green. And so we're looking at the projects that we're working on in North Africa have modalities of the possibilities of sending electrons to Europe, hydrogen through pipe, and ammonia through ships.
Right. And, we're common friends with Layla Benali, who used to work at CERA and is now the minister. She's
been an incredible leader for energy transition in Morocco.
Driving this bridge between Morocco and the continent.
Yeah.
So it's an exciting opportunity for you to be really part of that story.
Yeah, and the resource in that part of the world is just fantastic, both for solar and for wind. And there's a lot of open land that's available for producing green energy and green fuels. So it's an amazing opportunity for European energy of the future.
But even beyond Morocco, I mean, there's Africa, right?
Yeah.
And they're desperate for off-grid power. They don't have, the grids are very.
Yeah, and a lot of the power opportunities in Morocco, I think, in Africa, will likely start with the extractives, and so looking at mining companies that have operations, and lots of times they're mining minerals for green purposes, but they're using oftentimes not so green fuel sources in order to do the mining operations. And so being able to bring GigaWind to the very large energy consumer of the extractive industry is also a really interesting opportunity.
Asia?
Yeah, Asia is a fantastic opportunity if in certain parts of it. Unfortunately, a lot of it, the wind resource is quite a bit lower, and so one has to be a little bit more targeted. When you're looking at countries like Malaysia and Indonesia, one has to be a lot more targeted. However, the thing that's really fantastic with these larger turbines, as I mentioned earlier, is you can operate in much lower wind speeds. Right. And so for areas of the world that are not considered great areas of the world for wind energy today, we can actually start to deploy wind energy and open up energy security opportunities for these countries as well. Because a lot of especially like Asian countries, will import a lot of their energy, and so being able to have some indigenous supply of renewable generation is something that's very interesting to countries around the world.
Have you India?
So India.
I know a guy.
Yeah, India will be fantastic. We We don't have any operations there as of yet. We're very interested in it as a market. And again, if you look at the Indian opportunity, the wind speeds, if you can drop the average wind speeds down, you open up a lot more opportunity within India, within any other place in the world as well.
So, we've been focusing on wind and you're passionate about the energy applications. But if you look at the design and what you're building, there must be multiple applications for what you're calling wind runner.
Yeah.
But it could also be food runner or
right.
other
Yep.
runner.
Yep.
What's your
Yeah. If you think about where, if you step back for a second and say, what else can you use this for, and why are we in this position where we need an aircraft that's this large? You can sort of trace back the history of our terrestrial infrastructure to a couple of almost governmental decisions that limit terrestrial transportation today. So the width of roads is really can arguably be traced back to the Roman Empire, with the width of horses and carriages, and then we got to horseless carriages that drove on the same dimensionality of roads basically, and then into freeways today, all roughly the same dimensionality. Tracing back to the Roman Empire. And then if you look at the height limitations on bridges in the US and Europe are actually determined by a 1950s Atlas D nuclear missile on a flatbed. And that was the height limitation that we created for bridges in the US and bridges in Europe. And so if you think about those dimensional constraints that we have, both width and height, and certainly it limits wind energy in 2024, but it also limits the size of pharmaceutical tanks. It limits the width of rocket boosters. It limits the size of satellites. It limits the size of prefab housing. There's all kinds of things that can be moved with a much larger aircraft, and so the engineers, it'll open up a new dimension of opportunity for the engineers in all kinds of different industries. And then also there's humanitarian purposes for this. If you can land a very large aircraft carrying a large payload on a dirt surface, that there's obvious implications of that. There's some military applications. You can put a 6-pack of Chinook helicopters inside of the vehicle and land it on a dirt strip.
6 helicopters.
6 helicopters, 6 F-16s.
Like you think about it, it's a football field.
Yeah, it is. It's a very, very large
Are there
vehicle.
must be weight constraints.
Yeah, and so this is the first time that an airplane has been designed around volume instead of mass.
Right.
And so there's absolutely mass constraints, but we still carry a lot of mass, and around 75 tons. So it's a pretty substantial amount of mass, but it's really designed to move large volume. And there's a challenge right now in the industry because in the last few decades, if commercial industry wanted to move a big thing, so if you were an oil and gas company and you wanted to move a gigantic object, you would usually hire an Antonov to move a very large component around. And those are increasingly depleting, and they're not in production anymore. They're depleting, and also it's not permissible to use them in the Western world as a result of the sanctions from the Ukraine war. And so there's a gigantic gap in cargo airlift in general, and it's interesting to observe that there really is no cargo aircraft of any of size in production or really planned, military or commercial. And so the C-5s are depleting, the Antonovs are not available, the Ilyushin 76s are not available, and so there's a giant opportunity for cargo in general. We do believe that the biggest opportunity is moving wind blades, because for that type of business, you're in the supply chain, and every day you're just going to the factory and picking up a few blades and moving them to different wind farms. And so being part of the supply chain is a very powerful cadence of business.
So what's the timing? We want these faster. When will you?
Yeah, so the team's done a fantastic job of moving us through the process. The aerospace process has 10 different major phases. Broadly speaking, we're ready to enter into what we'd call, in the aerospace world, program launch, and in the energy world, FID. And so we're essentially preparing for that point later this year. It'll take a few more years to actually get first flight and into certification. But we're more than halfway through the process in terms of being able to get into to moving blades.
So this is, 4 or 5 year time frame?
Yeah, I think we'll have a robust business moving blades this decade.
Wow, so that's fast. relatively in this
Yeah.
industry.
Well, it's one of the beautiful things about the aircraft is the team's done a fantastic job of designing it around the tier one components that are already flying and already certified. And so by being able to do that, you do reduce the certification risk significantly and have some confidence to get into service a little bit quicker.
So I have one last question as we wind down, which is, you've been successful in all these other fields as an entrepreneur. Part of the concept of the Innovation Agora is to bring out entrepreneurs and inspire folks. What advice would you have for aspiring or budding or existing entrepreneurs out there trying to cut their teeth?
Right. I think one of the biggest decisions, of course, is what do you cut your teeth on, and so when I think about interesting opportunities in the world of entrepreneuring, there's sort of two different categories that I think of. There's either a brand new technology that requires probably a lot of R&D, maybe involves some deep physics, and that can be very powerful. The other type of entrepreneuring is pulling together things across industries that already exist, but maybe are not used in a different industry. And in that case, the risk can be quite a bit lower. The complexity of building the industrial ecosystem is higher, and so you need just fantastic management talent in order to pull that off, as opposed to scientific talent to go deep into new technologies. And so that's the first thing I think to think about. And then you look into your soul and say, do you have the stamina to go after something that could be a very long process and has its highs and its lows and hopefully mostly highs, and then once you get started, though, it's just fantastic. Like building a team, building the team and building an investor base is just like it's so fun, and it's so gratifying to be able to watch a product and an organization mature along together. So.
That's very. I think what you're saying is very wise. That you have to feel mission driven and not trying to focus on just the you've created a unicorn here, but that's not what it was about. It's really about solving this incredible problem and organizing a team, getting it done. So.
Yeah, and that is one of the unique things I think about what we're undertaking at Radia is the ability to bring a lot of aerospace expertise and aerospace companies into the world of climate change. So if you think about the aerospace industry and aerospace professionals, myself included, you generally don't have a chance to deploy your skills in an area that is considered to be very important in the world today of climate change. In fact, usually aerospace is kind of the bad guy in the room instead of the good guy in the room. And so it's wonderful to be able to use aerospace and use the Climate Air Force in order to be able to help reduce CO2 in the world. And if we're anywhere close to what Professor Jenkins I quoted earlier, and we can reduce the CO2 out of the grid by 15 to 30%, what a fantastic way to use aerospace companies and aerospace professionals in the energy transition. Right.
Mark Lundstrom, thank you very much for this wonderful voice of innovation.